Telewebinar, Solving Edge Communication Challenges for Industrial IoT. I'm Amanda Flink, the head of global events here at Telet, and I will be moderating today's event. To explain this topic, I'm pleased to be joined by Bill Dykes, our product manager for Telet DeviceWise. Today, Bill will be covering the industrial IoT edge and IoT systems management. As enterprises shift from basic automation to full digital transformation to bring new, innovative devices to the market, IoT solution providers face challenges in developing and delivering capabilities that fully match business goals and expectations. Bill will cover those challenges and how to connect DeviceWise as part of an OT to IT unified solution. Just before I hand it over to Bill to start the presentation, I would like to encourage our audience to check out the resources section in the upper right-hand corner of your screen for additional information on today's topic. Finally, we will send out a replay link to all attendees at the conclusion of this webinar. And with that, Bill, I will hand it to you.
Good day to everybody. We'll have an interesting look at some variations and different perspectives. Part of it is of who we are at Telet. So many of you may know of us for our very large business in cellular modules, but we also have a significant business in connectivity services and communication around the world. But we also have an IoT platform group, that business unit that I'm part of, and I'm the product manager for that. So let me just jump to a quick second. I know we've all taken our different lens on the edge, but I first want to state how important it is and maybe place it in a primary lens. I think what we've seen over maybe the last 5 years or so, and kind of a historical perspective, we sort of started in the application enablement platform, which was all kind of a singular platform for connecting, attaching, and creating applications, and that's evolved over time as other vendors with other skills have come into the IoT space. Companies like Azure and Amazon and IBM and Google, et cetera, and SAP and their cloud services, and of course they bring their lens of data storage, data manipulation, data analytics. But that lens sort of carried over, I think, also when we used to look at things, we view the house, or the previous lens was the sending data or video to a house was the last mile, and the edge started getting viewed as the last mile, and I think what the real way to look at it is in the concept of IoT. The edge is the first mile. Because if you don't capture that data, if you don't move that data, if you don't send it to be put into a proper business process application, whether that be a sales or a predictive maintenance or an asset monitoring solution, those IoT applications don't exist. So it's my belief and ours at Telet that the first mile kind of starts with the edge, and it's real important that we understand it. From my lens, I look at the IoT and the IoT platform as a data application. And so what's needed when you're dealing with the edge and you need real industrial, so you need to manage real-time data ingestion, and you need to have the business process rules and logic. And so the whole thing, that list of things there, they all add up to me to this idea of an IoT systems management. You're going, and there'll be another slide later on where I'll address some of those things specifically in terms of the kind of process of managing an IoT at the edge. So, and part of this is, the evolution, and it would be nice to think that the world of edge devices is easily connected to, and that it's evolved to all these pieces of digital equipment that are all being launched today with the idea of IoT primarily in the lens. But in the factories and the environments that we are in today, there's equipment that is not very easy to connect to and not very open. things that the IT world is used to, the industrial OT world, operational technology world, is kind of just getting to that point right now where you can do all of these things that we're talking about, remotely manage and deploy. And so it becomes becomes also a blend of data that we have to deal with in different types of equipment. So let me jump to the next slide here. When we think of an IoT platform, which is inclusive of the edge from our perspective, there's all kinds of layers that we're having to deal with in terms of the data flows. And I think it's really important that we understand that it's not, and in fact, it can often be a nonlinear flow where you can jump between these layers. It's not just going to a control system. It's not just going between that layer and then the next layer. You're looking at getting data from a low level and moving it up to the highest level, something you might say from the plant floor to the boardroom floor. So I think it's really important to understand these layers of the edge, and they're not just about transport. There's a transformation aspect here and the conversion into information for decisions at each one of these layers. And so from a connection perspective and a communication perspective, there's challenges because these layers aren't easily communicated. There are some open industry standards, but what we'll see is compared to native connections to these devices, the latencies and the ability for large volumes of data to flow are tricky. And as we start moving in, we start talking about private networks or inside of a factory private network that implements 5G type technology, latency is going to be, and the volumes of data are going to be critical aspects of this. So let me fill in the blank here. So our circle here is kind of the whole idea of edge component integration and the services that go with it. So what we see today in the IoT platform world, a lot of companies focus on device management, and that's well and good where you are either in we're talking about millions of devices coming on board, and how do you remotely provision and configure them? And so that requires some level of sophistication on the device or some sophistication of a kind of an aggregator device at the edge to manage all of those sensors and communicate and provide software updates. Next, there's typically some edge logic where we're defining and building some level of logic of what's going on at the edge. Some of it's for alarm purposing, some of it's for how you optimize the data flows, reducing data flows, because no matter what the cost or what the aspect of the, say, a wireless plan, it's always going to need to be optimized at some point in the future, if not right away. You're always going to be looking to reduce the flow of data. And so the question becomes, what is the right flow of data? It's getting the right data at the right time at the right rate. So that's optimizing those behaviors. And then as you bring these devices online, how are you securing? Not just securing the data flow, securing the data access. How are you pre-provisioning? When you start dealing with security and the device management and combining them into a solution, you're looking for the ways to make it so that before that device leaves the factory, it's already pre-provisioned for that vendor. Say a water meter vendor buys a particular cellular module from Telit, depending upon if it uses our OneEdge product, it's already pre-provisioned for that vendor so that when it's installed in, say, a water meter and that water meter then goes to the field, it boots up and knows where to boot up and what organization it needs to go to inside of a IoT platform to be managed. And then lastly, but not leastly, the connectivity services and management. in terms of managing. It may be a wireless service, and there's SIMs and other managing the network connection to it. But it's all part of the virtuous circle that we're calling here in industrial IoT systems management. And the last part of this is this enterprise integration. So this is all part of an edge, and the various layers of the edge in the end have to deliver the data to someplace for meaningful. It could be to have local visualization. It could be into machine learning or artificial intelligence systems. The right data at the right rate at the right flow is critical to those different enterprise integration systems. And I think what I'd like to say here is that this is not a single vendor solution in the sense that while we talked about this overall kind of edge component integration in a virtuous circle, the real IoT solutions are combined with different edge devices that need to be connected into through different IoT systems and data delivered into different business applications. For example, we have one example of a use case is a small construction equipment company that does 100,000 vehicles. Their application is, while we communicate with those vehicles and perform device management, our system and delivery of data is integrated into a very large enterprise system that deals with a multi-vendor solution. It may be Salesforce, it may be an ERP system, it may be a custom-made dealer management network, and also it may be a custom-made enterprise predictive maintenance solution. So the point is it's an edge integration deals with a lot of different data types, a lot of different data flows, and the rate that you've got to deal with all of these elements so that it can be delivered into meaningful, processed into meaningful business applications. So, so my point here is in an edge and intra-communication, it begins at the first mile, as we spoke earlier. And this is an example of how we look at and deliver value in terms of to the industrial IoT space. So, connected factories. Today, we're starting to see customers use software that previously were control systems and whether they be programmable logic controllers that manage paint lines or engine assembly lines. They still want to get data, but they don't want the process affected, and they need data in a timely manner. Typically, for example, might be for a quality assurance application, or maybe to present the data in a visualized way from robots and other industrial equipment into OpenHMI, data boards, and or pass the data on to local enterprise middleware for manufacturing execution systems, databases, et cetera. Similarly, when you start looking at remote industrial assets, and when we think of industrial assets, it can be everything from a fast food restaurant monitoring deep fry oil, which a fast food restaurant is a type of factory, or it could be a remotely operated oil fracking site with thousands of trucks that need to have data monitored for maintenance and performance on a regular basis. So there's a mixture of systems here that are presenting data at the edge, presenting data at the reporting level, and then moving that data possibly into larger applications that operate in the cloud, whether it be Azure, AWS, or some custom enterprise. But the point of this edge and intra-edge communication is it's as I said before, it's not a linear flow. And so you have to build with the thought in that you're going to manage the flows across different layers of applications, different layers of service, and it has to be done in a low latency, timely manner. I think one of the other aspects of this is, if you look, when we look at some of these things, for example, in a remote industrial asset might be a laser cutting machine that the original manufacturer is monitoring, and it could also be one of those construction vehicles, hundreds of thousands of them. Or it could, as I said, that laser could be a company that sells $1 million machines but only has 200 to 1,000. Which one is using the most data volume? In our experience, the couple hundred machines compared to the 100,000 machines is providing a lot more data because they're monitoring at a more frequent rate. So the data flows and the data control is critical to these varied applications. So let me take one example or create a picture for you that shows, look, if you're in plant 1 and you've got robots and other assembly machinery, you have to, ideally you're connecting natively to those machines. There are open system standards like OPC and others, but ideally if you can connect directly to that piece of equipment, you can collect that data faster and with low latency. And as time goes by, we'll start seeing cellular and non-cellular, for example, cellular meaning either private LTE or 5G networks inside of plants. And you might ask, why would companies build private networks? There's a variety of reasons. One, running hundreds and thousands of cables to wired machines across networks is very cumbersome, and it's very expensive, especially if you're wanting to reconfigure a factory every 6 months. So having a private network that can deal with the required latencies and quite frequently large volumes of data lends itself in the future to private networks. And so you might be doing that within a network, across plants, and then ultimately being able to send the data up to an IoT system management or other applications. So let's just say here that these deployments, while they look linear, there are definitely overlapping systems here. It's the collection, the connection, visualization, like we showed in the layer. These could be to a local system built in plant, or it could be sent outside of the plant to others. So I think it's important that when you connect the edge and you control the edge, you make sure that you can manage and deliver the data. So I'm going to present, like in the context, a little bit of detail of what's required, and these are using some of our TELUS products. But at the edge, you need a piece of software, an edge gateway running on local processing systems. It could be at the factory door, or it could be next to pieces of machinery. But these are critical elements of the edge gateway. The time series databases, edge processing, and you still have to administer the users and control the users and visualize the data, so that you can. And tag visualization is a critical element, so that you can tie these sensors in and reduce setup time and actually reconfigure depending upon what's required. Gateways need to actually have some store and forward mechanism if you lose your connection, and then security, and then lastly, how do you get it up to a larger platform for kind of a master system in terms of management and managing security certificates and automation and data visualization presents different levels of requirements. So at the edge, you're dealing with connectivity management, you're dealing with edge process control logic, business continuity, logging, data visualization, runtime monitoring, store and forward. These are all elements that are required to operate at the edge. And these features, either all or parts of them, need to operate at devices that may be as small as a small cellular router. When you move to the plant level, you have a lot more management, of more data. You have multiple edges combined into a singular edge, basically the plant network, where then you're tying into other enterprise systems that require more data management, data normalization, brokering, and other elements that I'll leave you to read right there. And then lastly, as we get up to the highest level, the cloud is the kind of the element that helps pull together all these edge components and manage the streaming, the buffering, and providing new ways to integrate the data into other enterprise business process applications. So with that, I'm going to stop right there.
Great. Thanks, Bill. I believe that's all the time we have for today. Please be sure to check your inboxes in the coming days for the replay link. Thanks again, Bill, for the wonderful presentation, and thanks to all who joined us today.